Okay, so we are going to be looking at transformations with sketching graphs. So this is connecting to 3F, but it's also linked to 3G of when we're dealing with power functions with positive integer index. So the first thing we need to make sure we understand is identifying the known graphs. We need to understand what is that parent graph. If there is any asymptotes, and then we need to apply a transformation. That is stretching, so dilation, it's reflection, and it's translation. So just be mindful that we need to be dealing with stretching before we deal with translation, and I'm going to talk to you about the reason and the why. Then finally, we can adjust our key features with intercepts and turning points to graph. So let's start off with this first graph. So the first thing that we need to be thinking about here when we're graphing is we need to be looking at what graph would 2 over x1 plus 3 be. So straight away here, I can see that it is going to be a hyperbola, and we know we've got an asymptote. Get the pen. We know we'll have an asymptote right here when x is 0, and we know we've got an asymptote right here when y is 0. The next part we need to be thinking about is there any transformation that will change where our asymptotes will be? And that's where we cannot divide by 0, so x can't be -1, so that will be one asymptote. And the other one is when that fraction is 0, we will never equal that plus 3, so that gives me my second of y equals 3. Just to find some key points before I do anything is I'm going to be looking at just substituting in 0 into my function, and that will give me the key a key point of 0, 5. And the next one will be substituting -2, and that will give me a key point of 1. I want to look at the dilation factor. So the dilation factor of 2 is from the x-axis, and that is this 2 here. All that is saying it's we're pushing up. So whatever our y value was, we're timesing by 2. Now I'm going to show you on the reason why we do this before we do our transformation, our vertical transformation and our horizontal transformation. Let me get Desmos up. It's a very good tool to be able to visually see everything. Okay, so let's start off with our basic graph of what y equals 1 over x. The next part I want to look at, if straight away, if I do my dilation, so say I've got 2, this is going to jump here. So my y value was 1, it's going to change to 2. So now from that point, then if I apply my vertical translation, it's then going to go up 3 from this point to the 5. So y is equal to 2 over x plus 3. So that's just been pushed up here. So we need to make sure that the dilation is done from the basic graph before we apply the vertical shift. Then I'll be doing the same as horizontally as well. Be applying the dilation, and then from that I will be applying the shift. So in this case here, now I've got this here from this point. This is my key point, and then it's being pushed over by 1 because it's got x plus 1 there. So if I put x plus 1, it's pushed over. So be mindful that a dilation must come before we do vertical and horizontal shift. So the next part is I want to look at the range. We know with our range for this type of graph, it can be all real numbers except for where the asymptote is. And the asymptote is at 3, so which means all real numbers except for 3. Then we've got our x-intercept. To find the x-intercept, here we just make y equals 0, and we solve and we get x is equal to -5 over 3. That's where I just put in my key points, and then I am able to graph it. Apologies about my graphs, I do not have a touch screen at the moment. Let's look at this next graph. We're going to sketch the graph and state again if we've got asymptotes, axis of symmetry, so axis, intercepts, and range. So to start off with, in this graph, we are not going to have asymptotes, so I can ignore that part. I need to know what kind of graph this is. So we know this kind of graph is going to start at the origin and it's going to go up. So that also tells me that in this state, the range is really from 0, can equal to 0, and it'll go to infinity, but it can't be negative because we can't have a square root negative. Transformation. From our dilation lesson, we talked about when we've got a 3 in front of the x, that is really just saying it is going to be compressed to the y-axis. So our dilation factor is actually 1 over 3 from the y-axis. We also have x plus 2, so that gives me my horizontal translation of 2 in the negative direction. There's no vertical translation, so straight away I can just say my range is from 0 all the way to infinity. It's a round bracket because it can never equal infinity, and it's this bracket here, the square, because it can equal 0. X-intercept we already know because it's starting at -2. Our y-intercept, we are just going to make x equals 0, and that will give us square root 6. So the next part, when we are graphing, I'm just going to put the basic graph on, and you can do this. It will help to visualize and make sure you're labeling what it is. So I know it's partly off the screen, but I've got y is equal to square root x. The next part with our dilation is being compressed, so it's 1/3 of this. So it's going to go through here. So I've got y is equal to square root 3x. And then from this point, I have that horizontal shift in the negative direction by 2. So 1 and 2. From that, I have labeled my points. So be mindful. Please use dilation before you doing the horizontal and vertical shift.